I'm Rockey Luo at the Electrical Engineering Department, and I got my PhD degree from University of Connecticut in Electrical Engineering in 2002, and I have been in University of Maryland, College Park after that, and before I joined Colorado State University. So my research focuses on obtaining fundamental understandings about wireless communication networks. We're working on several projects in diversified research areas. So I would like to introduce two here. And the first topic is in the area of ad hoc networking. And ad hoc network refers to a network that whose operation doesn't depend on any fixed infrastructure. And the idea is the following. For example, in a battlefield environment, if the soldiers, vehicles, and robots are located within certain range, we want their communication devices to automatically form a network in whatever way to connect them. To support information exchange and the collaborative operations. So such flexible networking capabilities not only important in special situations like battlefield communication and disaster recovery, it can also bring dramatic flexibility and robustness to our commercial networks and other networks, and can also significantly improve the energy efficiency of those networks. But the problem is to efficiently design such a network face many challenges. For example, the mobility of the nodes, the interference among parallel transmissions, and the uncertainty and time variation of the channel conditions, and the battery power limitation and the bandwidth limitations. And also communication devices can be heterogeneous, and the different applications can have different performance objectives, etc. So with all these challenges, it's very important to find out what are the key principles an efficient network design should follow, and what are the key properties an efficiently designed network should have. So this is what we mean by fundamental understanding, and these key principles and key properties are really the things we're looking for. So another project I want to mention is in the area of opportunistic spectrum access. So spectrum and or frequency bandwidth is really a scarce resource in wireless communication that has to be shared among all wireless systems. So in current federal spectrum regulation, spectrum is divided into chunks, and each chunk is called a frequency band. And the frequency band is either exclusively assigned to a group of licensed users, or simply it is open to free public access. So these are the two models to share the frequency band. And the inefficiency of these two models are kind of obvious. Like in the first model, even if the licensed users are not using the frequency band at this moment, no unlicensed user is allowed to access that resource. And in the second model, all users are treated equally, and this is not the best way to share a scarce resource as well. So the idea behind the opportunistic spectrum access is to do something in between. Like we define high priority users and low priority users, and we allow low priority users to access the frequency band if their communication activities do not disturb the high priority users. So the idea is very simple, but if you think more, it's actually not very easy to do. One problem is the following. If we define a priority structure like high priority user and low priority users, we should also have certain mechanism to enforce such a structure, in the sense that if the users do not follow the spectrum regulation, you should be able to effectively detect and discourage these violations. Doing research in these topics requires an integrated consideration of many parameters, and you need also trade-off different aspects of a system. So I believe it is very important to have a broad vision, that you understand how a research topic connects to other relevant areas. And you also need to know that how to formulate a problem in an innovative way to enable the derivation of the interesting results.